Hello class. Today I'm going to present you homework number 2, which is going to be about boundary layers. We learned different types of boundary layers. As you can see in this presentation, we have a specified temperature boundary layer, which is going to be a constant number. Sometimes we call it isothermal boundary layer. We assign a temperature directly to that, to the object we want. We could have convective boundary layer, so convection happens there. Radiative boundary layer, radiation. Heat flux, we can have any number of heat flux over the object we have. It could be a combination of different boundary layers. Interface boundary layer was the boundary layer which we had same conduction, same temperature, different conduction at the interface, which is ANSYS needs to take care of that part. And so that is why I decided to design a homework regarding boundary layers. Let's see what is the homework number 2 is about. Same geometry we had for homework number 1. So it's a bar with rectangular cross-sectional areas. Everything is same. This time, I'm asking you to find temperature at the center of this bar, which is going to be here, for these 3 different boundary conditions. Left side 80 degree, right side 40 degree, and surrounding walls adiabatic. So left side 80, right side 40, and these 4 walls around is going to be adiabatic. This is exactly similar to the case we had for homework number 1. Case number 2, left side is going to be 80 degree, right side 40 degree, and surrounding is going to have convective boundary layer with T infinity 22 degree and convective coefficient 15. When convective coefficient is 15, and you should know that it's a small number, it should be natural convection phenomena. And the third one, again 80 degree left, 40 degree right, and surrounding this time is going to have radiative boundary layer. For radiation, you need to know what is the stream temperature, or T infinity, and external emissivity, which usually between 0 and 1. Let me show you the boundary layer and how you can assign those boundary layer. You need to open your ANSYS Fluent from the previous homework, open setup, and then it is going to open automatically Fluent. You need to go to boundary conditions. We assign these 3 names: left side, right side, and wall, which is going to be side walls. So for example, let me open the left side just to see what type of boundary conditions is available in ANSYS Fluent. Okay. Let's see. The first one is heat flux. Heat flux can be any number you want, you can assign here. So if we check this homework, the first one says 80 left, 40 right, and adiabatic. And you know adiabatic means 0 heat flux. So you need to assign adiabatic or 0 heat flux for the side walls. For the left side and right side says 80 degree and 40 degree. So you need to come to here, select temperature, and assign that temperature for the left side, and again repeat that for the right side with different temperatures. The third boundary layer is convective boundary layer. As you can see by clicking here, it adds a few more items, which one of them is free stream temperature, T infinity, or temperature of the fluid around the object, and heat transfer coefficient or convective coefficient, which is currently 0, so no losing heat or gaining heat around, so you need to add some number. We assign 15, and you know between 5 to 25 it's going to be natural convection for gases, so it's a natural convection cooling. And the fourth one is going to be radiative. We have emissivity between 0 and to 1, and again stream or external radiation temperature, again T infinity, which you need to assign here. Number 5 is going to be mixed, which is mixed between convection and radiation. As you can see, it asks for convection boundary layer parameters and radiation boundary layer parameters. And number 6 is going to be coupling. If you had another system and you wanted to couple with that, you are going to use that one. And the last one says via mapped interface. And we talked about this. It's about when we had two objects in contact with each other, but different materials, the temperature at the contact or interface is going to be same, but conduction or conduction coefficient for the left side and right side of that interface is going to be different. This is going to create a jump. We don't like any big jump of thermal conductivity. That is why we need to tell ANSYS to take care of that. So here you can see all different types of thermal boundary layer we have. You may see this wall thickness here and material name there. We use these two options when we have 1D case or shell conduction calculation. What I mean, when we have 1D case, you need to specify some thickness for that wall and material. Or sometimes you are working, for example, heat exchangers. They have some layers, very thin layers inside those heat exchangers. When you are meshing those very thin layers, the mesh size expansion is going to be a little bit problem. And to overcome that problem, we can specify wall thickness instead of 0, put some number, for example 0.001, which is going to be 1 millimeter of thickness, and assign the material for that, and it's going to help us. Normally we don't use it. Okay, so these are all the options we have for thermal boundary layer. That's it. See you next time.